This video will serve as a brief introduction into aromatic compounds. Specifically, we'll look at benzene. And then after that, we'll take a quick look at a nitro group. Benzene is a common organic molecule. It's used as the building blocks of many pharmaceuticals. It's also a common solvent. Benzene has 6 carbons and 6 hydrogens. The unique thing about benzene is that the carbons are arranged in a ring. Now you can see that the carbons have alternating single and double bonds. And notice that each carbon also has 1 hydrogen bonded to it. Now this would be pretty difficult and time-consuming to draw, so we've developed a shorthand way of doing it, simply like this. It's a hexagon with alternating single and double bonds. You may be wondering if it matters where the double bonds are positioned, and the answer is that it does not matter. You can position the double bonds anywhere you'd like, as long as they're alternating single and double bonds. Now we've also studied resonance a little bit, so you may have guessed it's actually more like a hybrid of the two of these. So if you choose, you can also draw benzene kind of like this. So either one of these will be acceptable. Now let's take a look at benzene. We're going to look at 3 benzene rings with some substituents attached to it. 2 chlorines attached to this one, 2 chlorines attached to this one, and 2 chlorines attached to this one. Notice that these are the only 3 possibilities in terms of arrangement. We can be attached to the first and second carbon, the first and the third carbon, or the first and the fourth. Those are the 3 options. These type of arrangements are so common on benzene rings that we have special names for it. If they're on adjacent carbons, it's called ortho. If there's 1 carbon in between the 2 substituents, it's called meta. And if the 2 substituents are located opposite each other, it's called para. So let's try to name these 3. You know that this is benzene. We have 2 chlorine groups attached to the benzene, so it's going to be dichloro. But we want to say the position of the 2 chlorines. So it's ortho dichlorobenzene. Or we can just call it O dichlorobenzene. Let's try the next one. Also benzene and 2 chlorine substituents, so that would be dichloro as well. But let's indicate once again the position of the chloro groups. So we'll say meta dichlorobenzene, or M dichlorobenzene. And this last one, you guessed it, para-dichlorobenzene, or p-dichlorobenzene. You'll have more practice working with benzene on the homework. Now sometimes benzene is a substituent. When benzene is a substituent, it's called by the name phenyl. For example, here we have a parent chain. Looks like a pretty long chain. Let's count them. 1, 2, 3, 4, 5, 6, 7. So something with 7 carbons, that's called heptane. And we have a benzene group located on the second carbon. But remember, when benzene is a substituent, it's called phenyl. So it's 2-phenyl heptane. Should be written like this. Heptane, because the parent chain has 7 carbons, and 2-phenyl, because the phenyl, or benzene, is located on the second carbon. So 2-phenyl heptane. Now benzenes are so common, you'll see it in a variety of pharmaceutical drugs. For example, here's a benzene ring. The name of this drug is Advil. Here's another common drug. This also has a benzene ring in it. This is acetyl salicylic acid, or aspirin. Here's a third example. There's the benzene ring. This is Tylenol, or acetaminophen. Benzenes are everywhere. Try to familiarize yourself with it.